Koichi Sato, the CEO of Toyota, paused mid-sentence as the overhead lights dimmed. The sleek form of the Aquat engine now illuminated like some mythic artifact. It hummed quietly in the contained silence of the demonstration hall, seemingly powered by nothing more than a simple bucket of ordinary tap water. He didn't need to elaborate, the implication was clear. In that charged moment, an unspoken declaration hung in the air. This innovation could very well upend everything the EV industry stood for. Across Japan and then around the world, the ripples were instantaneous. Observers struggled to reconcile the familiar image of Toyota, quiet, methodical, almost conservative, with this electrifying revelation, an onboard electrolytic reactor that separated hydrogen from water in real time, feeding a compact fuel cell and delivering power with no fossil fuels, no grid, no lithium, just water. A closed-loop hydrogen system, clean and almost poetic in its simplicity. The engine consumed tap or rainwater, refilled in a couple of minutes, and promised over 900 kilometers of range. The future didn't come draped in wires and batteries, it came in the elemental purity of a water molecule. Immediately questions swarmed. How could Toyota have achieved something so revolutionary so quietly? Stagecraft was subtle yet powerful. He didn't scream that this was the end of electric vehicles, he let his creation speak for itself. The audience already understood. Refueling in 2 minutes with water, that alone dismantled years of infrastructure investments in charging networks, battery supply chains, lithium mining, and grid expansion. It was too elegant, too radical to ignore. Journalists scrambled for clarity. Was this a fuel cell? No. There was no high-pressure hydrogen tank, no external hydrogen station. The hydrogen was born inside the engine on demand. The only byproduct, water vapor. That meant zero emissions, zero reliance on battery materials, and no requirement for rare earth elements. It was molecular fuel, pure and simple. In the marquee corridors of the electric vehicle industry, the shock was, well, seismic. Battery giants, who were once reveling in headlines about market dominance, now found themselves confronting a whole new paradigm. Lithium futures dipped, stock charts wavered. Tesla, BYD, Rivian, all of them tentatively retreated into their boardrooms, reassessing strategies. Traders whispered about stranded assets. Planners looked at charging infrastructure with, fresh trepidation. At the same time, environmental groups erupted in applause. Here was a technology that offered a credible path toward decarbonization without further exploiting fragile ecosystems, or honestly, inciting geopolitical tension over mineral mining. The possibility of mobility powered by water, a form and function fused with environmental ethics, had an almost mythic allure. Governments, initially cautious, now pivoted. Regulators scrambled to define safety frameworks. Was a sealed reactor that split water on board truly safe across temperatures, altitudes, and, traffic conditions? What about use in cold climates where water freezes? Toyota's certifications, including Japan's top environmental and road safety clearances, assuaged many fears, but not all. Lobbyists raised alarms. If water-powered engines proliferated, what would happen to economies built on lithium, oil, or even electricity grids? Would desalination plants be repurposed? Would rainwater harvesting become a new focus? And all the while, Toyota moved forward with exceptional stealth and confidence. The Aqua engines were already in production at the Higashi Fuji plant. Plans called for the first vehicles, starting with the Mai AQ, to roll out as early as the first quarter of 2026. Ambitions didn't end there. Commercial trucks and Lexus models were next in the pipeline. Exclusive patents on the electrolytic reactor meant competitors couldn't easily replicate the technology. Perhaps most intriguing was the modularity that hinted at future scalability. Toyota's engineers had designed the Aqua to be adaptable, with core components that could be scaled up or down depending on the application. A city bus could house a larger electrolytic chamber for greater hydrogen throughput, while a compact urban commuter might operate with a smaller, lighter system. This flexibility meant the technology could saturate multiple transport segments simultaneously, rather than waiting for a trickle-down effect from one class of vehicle to another. In research institutions, the unveiling triggered a renewed focus on complementary technologies. Advances in atmospheric water harvesting, for example, could pair seamlessly with the Aqua, allowing vehicles to generate their own water supply in humid climates. New materials for even more efficient electrolysis could push the system's performance further, while AI-driven route optimization could reduce energy demands to the absolute minimum. The social implications were equally significant. In developing regions where access to fuel is often limited or, prohibitively expensive, a vehicle that could run on collected rainwater or locally sourced non-potable supplies could really transform mobility. Farmers, traders, and rural healthcare providers could travel farther and more frequently without the economic strain of conventional fuel costs. Mobility itself could become more equitable, no longer restricted by the location of fuel supply chains. As engineers demonstrated the ease of operation to small groups in the hall, it became clear that user interaction had been a design priority. A single dashboard indicator displayed water levels, projected range, and hydrogen production rate in an intuitive format. There were no complex controls for the driver to manage. The system's AI handled everything from flow rates to temperature balancing. The driver's only task was to ensure the reservoir was topped up, a task so straightforward it required no special training. The demonstration concluded not with a roar, but with a sustained, thoughtful hum. As the house lights rose, the initial silence gave way to a low, urgent murmur as attendees reached for phones, their voices a mixture of awe and disbelief. The questions began to crystallize, moving from stunned what-ifs to pressing hows. Financial networks were the first to react with tangible force. Pre-market trading saw a sharp correction not just in automotive stocks, but across the entire energy sector. Shares in major lithium mining corporations and charging infrastructure companies plummeted, while companies specializing in electrolysis technology and water purification saw unprecedented volatile spikes. Analysts scrambled to issue new forecasts, many labeling the event a black swan moment that fundamentally invalidated long-term projections for the energy transition. The engineering community, really dissected the available information with some intense scrutiny. Online forums just erupted with debates over the reactor's efficiency, the energy balance of the electrolysis process, and the durability of the membranes that separated hydrogen from oxygen. Skeptics pointed to the laws of thermodynamics, demanding to know the exact energy input required to achieve such a high yield. Meanwhile, proponents countered with Toyota's renowned meticulousness and their possession of full certifications, arguing that, a public reveal of this magnitude would not occur without irrefutable data. Meanwhile, in developing nations, the news was met with a sense of revolutionary possibility. Governments and entrepreneurs saw a future where energy independence was not a distant dream, but a near-term reality. The prospect of powering transportation with rainwater or brackish water, free from the volatility of global oil markets or the need for massive electrical grid overhauls, presented a paradigm shift. NGOs began drafting proposals for pilot programs in remote communities, envisioning a new era of mobility for farmers, traders, and healthcare workers. Back at the demonstration hall, the Aqua engine itself stood silent, its work done. It had not just presented a new technology, it had thrown a stone into the stagnant pond of the energy debate, and the ripples were now spreading outward, set to touch every corner of the global economy. The age of the battery, it seemed, had suddenly acquired a formidable and utterly unexpected rival. For Toyota, the unveiling was also a subtle statement of independence from dominant industry trends. While other automakers were betting heavily on solid-state batteries or extended-range EVs, Toyota had stepped sideways into a space with little direct competition. This move insulated the company from some of the fiercest battles over battery supply contracts and charging infrastructure partnerships. It also positioned them as a supplier of not just vehicles, but of an entirely new propulsion ecosystem that others might license in the future. The room's atmosphere during those final hours was one of measured excitement. This was not the frenzied hype often associated with tech reveals. It was the quiet acknowledgement of witnessing a step change in what was thought possible. Industry veterans, normally skeptical of grand claims, found themselves discussing practical deployment timelines rather than feasibility. Startups whispered about pivoting to support services, from water logistics to aftermarket upgrades. Policymakers in attendance considered how existing fuel taxation models might adapt when water became a primary transport fuel.